G'day guys, number 35, CARCASE dovetail joint. Okay, now dovetails, I have to just go through with you guys a little bit quickly some information about dovetails before we get started, because the next few drawings are all like dovetail kind of drawings besides that one. Yeah, just a little bit about the information about dovetails. So this light piece of timber we have here, this is called the tailboard, right? This is the piece that has the actual dovetails on it. See this kind of, I guess you call it a trapezium shape. It's the piece, it's the part with like the slopes on it. The reason it's called a dovetail is because that's the kind of shape of a dove's tail, I guess you could say. And this darker board at the back, the one that joins into it, this is called your pin board, right? So these darker bits here, they're called the pins, right? So those pins are, they're in the pin board, and these tails are on the tail board, right? So we've got the tails and the pins. They're the two sort of components of a dovetail joint. So I'll just explain the rest as we go. We can see we've got a piece of 140 by 19 and it's 140 high. So let's put that in. 19, 140 and push it up by 140. All right, triple click, right click, make component, create. Okay, now I'm going to double click on this and we need to start laying it out. So when you get a workshop drawing, say this was like later on, you can see we're going to be drawing some projects. This is just an example, so I've given you a lot of dimensions. But normally in a drawing, if it's asking you to put dovetails in, it's sort of up to you as the maker as to how many dovetails you want to put in, what the slope you want to put, how many tails, how many pins you want to have, that kind of thing. For these practice ones, I've done 2, 3, some misshapen dovetails, and then 5 over here. But you can see here it says dovetails spaced evenly. So we know we've got two, the dimensions given to us are the tops of the tails are 60 millimeters wide and they're spaced evenly. So we have to measure those out from the center, right? The shoulder pins are half of the center pin, it tells us. So that means here, see that one there and that one there, they are our shoulder pins and that's our center pin, okay? So when it says it's half of the center pin, that means, I'll just zoom in so we can see, that means this measurement from there to there is half of what it is from there to there. So the center pin at the top is the widest, and then that is half. I'm pretty sure that's how dovetails are traditionally done. Your shoulder pins are usually half of what your center pin or center pins are. Like here, where you've got a lot of dovetails, your shoulder pin there is half of what your center pins are, if that makes sense. Should start making sense the more we do the dovetails. For starters, because we need to space them evenly, we need to find our center point. So because this piece of timber is 140 wide, the center will be at 70 millimeters, if my math is right. Now, it hasn't given us, this drawing doesn't give us the dimension of the top of the center pin. Okay, so we need to do a bit of math to figure that out. So let me zoom in. There we go. So we can see we've got 60 millimeters for that and 60 millimeters for that. That leaves us, those two added together is 120 millimeters. So the top of this piece of timber, of the 140 millimeters, 120 millimeters is taken up by the tail, right? So that leaves 20 millimeters left over for the pins, okay? So we know that this part here and this part here add up to one of them. So if you think about it, we just need to calculate 2 pins, right? Because we've got 1 full pin and 2 half pins. So left over, we have 20 millimeters. So if you divide that by 2 for the, I guess you could say 2 pins, they're going to be 10 millimeters each. So that's going to be 10 millimeters. And then because that's half, that'll be 5 and that'll be 5. So that 5 and 5 adds up to 10. That adds up to 10. So we've got 5, 60, 10, 60, 5. If you add all those together, that should come to 140. It might have been a bit of a complicated way to explain it, but it should make sense when we start going. So we know that we've got to mark out the center pin first. So that has to be 10 millimeters wide. So 5 millimeters out each way from the center. Okay. Then here, we need to go 60 millimeters across. And from here, 60 millimeters across. Okay. So that's 60 millimeters wide. That's 60 millimeters wide. Now I reckon if we measure that, it's going to be 5 on the dot. Perfect. Same here, it should be 5 on the dot. Perfect, 5 millimeters. Okay, now we need to, when we're doing the dovetails, measure down the thickness of our joining piece of material, which is 19 millimeters. So from here, 19 down, that didn't work, why not? 19, there we go, and go straight across 140. There we go. Right, now the pitch of these dovetails, we've done a few different dovetails before. I think they were all at a pitch of 1 to 6, so we need to do a pitch of 1 to 8. So again, let's show you how to mark it out. We'll do it on the back side. This is how you'd normally set up your sliding bevel when you're doing it in the workshop. We pick a corner and we measure 1 unit out this way. So we'll say 10 millimeters is our unit, right? And however many units or whatever the unit was we went that way, we need to go 8 times this in the opposite direction, or in the perpendicular direction, I guess you'd say. So we went 10 out that way. So 8 times 10 is 80. There we go. Now we've got to measure that with the protractor. So if I hover over that point there, click on the start point, go up to here, the angle tells us it's 82.9. It says roughly 82.9. See that squiggly line? It says 82.9. So because this, we're just in this drawing, we're just doing it to showcase the dovetails, I guess you could say. We're just trying to show what they look like. It doesn't need to be bang on perfect like it would have to be in the workshop. So let's say it's 83. That'll make our life a bit easier. So it's going to be 83, or if we know the difference between 83 and 90 degrees, we could type in 7. Okay, so let's swing back around to the front. We'll get the protractor up, which is, we've got it. We're going to go from this point. We need to be on the red axis, so hit the right arrow, click. We're going to go straight down, click, and then we need to go in an angle of 7. Right, there we go. And there's that angled line. It's the exact same thing here. We've got to click here, get it straight down on the blue axis, click again, and then type in 7. Okay, so that's a little bit less steep than the 1 to 6. It's a little bit, I guess you could say it's a little bit straighter than the 1 to 6 angle we were doing before. But yeah, so that's laid out now. Now we could go through and draw the angles on for this piece as well, or we could draw it here and copy those lines across. I'll show you how to do that. So we're going to click here. Hopefully it'll let us click on that point. No, it won't. Okay, that's fine. Like we did in the other one, we're going to have to click on this guide point over here, draw straight across, click, then it'll let us click on that line. On the intersection, bang, intersection, bang. So that's in there. Now what we need to do is grab the select tool. We're going to click on that line, and then we're going to hold down shift and click on that line. So we've got those 2 lines highlighted. Going to grab the move tool, hold down or press control, and see how that little plus icon comes up. Then we can grab it at the end point here. Don't grab it in the center of the line, grab it at that end point, click, and see how we've grabbed those 2 lines. We can now move it over to that guide point, and it should line up perfectly. Okay, see how that works? We need to now remove the unwanted lines. So we don't need that line, we don't need that line. Now I think we can just straight up push those through like that, and like that. Okay, so we can see that we've finished our tailboard there, right? So we can leave that. We can probably delete our guides. I don't think we're going to need them now. Now, that's our component done. We need to put in the pin board component. Now, this one is heaps easier than the one we just did because we can just trace what we've done. So we need to put in 140 by 19, enter. Push this one through, it's 140 millimeters. Double click, right click, make component, create, double click on it to edit it. Now we need to remove the tail parts, right? We need to remove that bit and that bit. So again, this is nice and easy. We can just trace there to there, there to there, there to there, there to there. Okay, and then we can push these in 19 millimeters. Double click that, that's in 19 millimeters. Now I reckon if we go out and we paint it, where's the paint bucket? This one's light, this one's dark. That is a perfect fitting dovetail joint. Okay, we'll just check it with the move tool to make sure we didn't make any mistakes. Yep, look at that. Slides in perfectly, nothing's clashing. That dovetail joint works. Right, so all the dovetails we do from here on out are a variation of what we just did, right? Because we sort of copied these 2 lines across, if the dovetail has, or the dovetail joint has 5 tails, 6 tails, 7 tails, you can just mark it out the same and copy your lines across. And the more you practice it, the better you're going to get at it. Okay, so we'll save this one. as number 35 carcass dovetail. There we go. And I'll see you in the next drawing at number 36 carcass dovetail 2. So there's a bit more dimensions on here for us, and we've got 3 dovetails in this time. So I'll see you in the next video.